presenting the design of low-power high-speed to level 3 input XOR gate. By Chaitanya Kommu and Daisy Rani. The large fan-in and high-performance gates are essential to make portable electronic devices. The efficient realization of high fan-in XOR gate defines the performance of digital circuits like adders, magnitude comparators, etc. In this paper, an efficient realization of 3-input, 2-level XOR, exclusive OR, is presented. The design of low power and high speed proposed XOR gate involves the combination of pass and transmission gates. The main objective to achieve this is based on the selection of input signals to propagate and maintain the good logic swing. The exclusive OR gate is a fundamental building primitive for adders which are mostly used in almost all the arithmetic circuits. Two methods were used to design the proposed XOR. One, i.e. pass-gate, is purely based on pass transistors with 8 MOSFET, and the second method, modified_pass_gate, uses transmission gates with 12 transistors. The modified_pass_gate offers 86.14% and 6.66% power dissipation reduction compared to static and pass_gate XOR, respectively, and 77.18% and 50.94% less propagation delay compared to static and pass_gate XOR respectively. At the supply voltage of 0.7 V with input signal frequency of 3 GHz. The simulation is performed based on a 32 nanometers technology node, PTM models, using the HSPICE synopsis simulation tool. From the simulation, it is evident that a definite advantage is in favor of the proposed XOR gate designs, especially for the combination at 0.7 V and at 3 GHz, the average power Thank you for watching this video. Please subscribe to our channel to watch more scientific videos.